So here we are. I'm going to do a few examples of doing some calculations and measurements with a topographic map for the natural history class. This is, we'll look down here, the Greens Creek, North Carolina map. It was made in 1940, so a pretty old map. There's probably new features on the landscape, particularly buildings and things like that. But the terrain most likely hasn't changed very much, so still a useful map. The contour interval is 40 feet. So from every one of these orange lines, the change in elevation from one line to the next is 40 feet. So you're looking at some pretty steep terrain here. Remember, every fifth line is darker. It's the same change in elevation. It's just every fifth line is darker to help you interpret the map a little bit more easily. And the scale is the standard scale of 1 to 24,000. So that's a relative scale. So one unit of anything on the map equals 24,000 of those on the ground. So that can help us figure out distance between points. So for this example, hopefully you can see we've drawn some lines to go parallel. We've drawn some north-south orienteering lines on the map to help us orient our compass. These are connecting the UTM coordinates or are simply parallel to those lines. And in this case, let's say that I was at this house. Hopefully you can see that black square that represents a building at the end of this Jeep trail. If I'm at that building and I want to go to High Top, this point, this peak here, that's also the intersection of some political boundaries. If I needed to know what direction to go, well, I know it's southwest, right? North is always on the top of my map, so I know that I want to go in some direction to the southwest. But I want to find what the degrees are from the house to High Top, that point labeled Dillsboro, 4,009 feet of elevation. I take the edge of my compass, I line up those 2 points, I connect them, and then I turn the compass dial until those black lines in the dial, those orienteering lines, are parallel to those north-south lines that we've drawn on the map, or if we have UTM coordinates already on the map. And then I would read what direction it would be. And in this case, it would be about 215 degrees. So I would be going, if I was starting here, I'd set my compass at 215. And as long as I've corrected for declination, I could walk. And if I could walk a straight line, I should arrive at High Top. I also might want to know how far that is. And so to figure that out, I could measure the distance. And so if I line up my 1 inch mark here, and then line up my other edge of my compass there, it looks to be about an inch, right, from 1 to 2, an inch, and let's call it an 1.75 inches. And so I could figure that out, right? 1.75 inches on the map times 24,000. If I had a calculator, which I do, 1.75 times 24,000 tells me it's 42,000 inches. If I want to know how many feet, simply divide by 12, and that's about 3,500 feet. So it takes me, it's going to be a little bit less than a mile, right? It's a mile, 1 mile equals 5,280 feet. So it's about 6 to 7/10 of a mile. Now, what if I didn't have a ruler with me? What if the compass I was using didn't have a ruler? Well, I could use any other device that I had. So say I have this chewed up hickory nut I found on the ground, and I took my hickory nut and measured how many hickory nuts it was from one point to the other, right? For me, it looks like about 2 hickory nuts. Then I could take my nut, this hickory nut the squirrels chewed up, come down to the scale bar, and the hickory nut is a little bit less than 2,000 feet. And so I could get a rough approximation just using this chewed hickory nut that it's about 2 of these, a little bit less than 2 of these. So it'll be a little bit less than 4,000 feet, right? And I could figure that out pretty finely. If I had a different measuring device, I could use my thumb, and it's how many thumb widths is it, right? I could make a mark. It's 2 1/4 widths of my thumb, and I could do the same thing using the scale bar and come up relatively precisely about how far it was going to be from the house to that high top measurement. So you don't even need a ruler to do some of this stuff. You can simply use whatever's in the field as long as you have access to the scale bar of the map. And again, change in elevation. If I wanted to know the change in elevation from high top to that house, I could simply count the contour intervals, figuring out the closest one to where the house is, and count them and come up with what the difference in elevation is. Basically, how far up am I climbing when I leave that house? Or I could follow around and see if I could find the closest labeled interval, and that would give me a good sense of that too, right? So this one is 3,200. Could follow that around. 3,200. This would be 3,160, 3,120. This would be 3,080. So I'm basically at 3,080. And I know this is 4,009. So it's going to be about 1,000-foot jump in elevation, a little bit less than 1,000 in that 3,500 feet of climbing. So again, contour intervals, these were 40-foot intervals, so I'm just counting that, multiplying by 40. I used this conveniently labeled one to give me a shortcut so I didn't have to count them all. And this just happened to be labeled as well. If it wasn't labeled, I would just go to the nearest contour interval and figure out what that is to do my estimate of change in elevation. So pretty simple stuff with a topographic map, but useful to help you plan your route and figure out how far it's going to be, and maybe to find out if there's an easier way to get from point A to point B where you don't have to climb such a steep slope, or you can avoid a swamp simply by plotting a different course.